Alright everybody, in this video Mr. Longo is going to cover how we model quadratics. And I don't mean like a fashion show, I mean when we are given certain information and we write the quadratic model that addresses what we are given. So before we jump in, you have to remember your three forms. We have a vertex form. Now vertex is a times x minus h squared plus k, where h comma k represents your vertex. We have intercept form, and that's a times x minus p times x minus q, where p and q are your x-intercepts. And then we have standard form, which isn't really going to be giving us any magical powers here. The only thing standard form does is tell you what the y-intercept is. It's 0 comma c, but that's not going to be that helpful in what we're working with right now. So what we need to do is kind of jump into a couple of these and you'll kind of have a better idea of what we're doing. So example number 1. We're going to write the vertex form equation of a quadratic function with, and here's the key information. We have a vertex of 3 comma 5 and passes through another point 6 comma negative 13. Now we have plenty of information. The first thing I would recommend that you do is write out your formula for vertex form. So that would be y is equal to a times x minus h squared plus k. And now we're just going to use a lot of substitution. So we have everything except for the a value. We know our vertex is h comma k, and we know our points are always x comma y. So we have enough information to solve this. So start substituting everything that you're given. So y is negative 13. That's equal to a, the only thing we don't have. X was given as 6. Our h value is 3, so minus h would be at minus 3 squared plus our k value of 5. See, look, we had everything. We just have to solve for a and then rewrite the equation. So 6 minus 3 is 3 squared is 9. So we have a negative 13 is equal to 9a plus 5. Subtract 5 from both sides. We have a negative 18 is equal to 9a. And we know that a is equal to a negative 2. So we used everything we had to solve for a. But we're not done. We have to write the vertex form equation. So now that we know what a is, we just go write y is equal to negative 2 times x minus 3 squared plus 5. Okay, so what you need to do is take what's given, solve for your a value, and then go back and write the equation. And that's the exact same thing we're going to do in our next example. The only difference is this time we want to write the intercept form equation. So it's going to start out the exact same way. Y is equal to a times x minus p times x minus q. But the rest is going to be the same as what we just did. So I would like you to pause the video and give this one a try on your own. As soon as you're ready, click play. So let's see how you did. So our y value, of course, is going to be our negative 9. And that's equal to a. Now we have x showing up twice. So we're going to use it twice. X is 2 both times. Now we have minus p and minus q. So our p and q are going to be substituted in as minus a negative 1 would turn into plus 1. And minus 3 is minus 3. So we have a negative 9 is equal to a times 3 times a negative 1. So negative 9 is equal to a negative 3a. So divide both sides by a negative 3 and a is equal to 3. So now that we have a, we just have to write our final equation, which is y is equal to 3 times x plus 1 and x minus 3. Okay? And that's it. That's all we had to do. Now the last one is different. The last one is when we are given 3 points. Now, your calculator can actually do that using a quadratic regression, but I'm going to show you how you do it the real way. So then that way you have more of appreciation for your calculator. When we're going to write a standard form given 3 points, we have to use what is known as a system of equations. And I'm going to show you how to do that. But we need to know that y is equal to ax squared plus bx plus c. Now all of these are xy, xy, xy. We don't have any a's, we don't have any b's, we don't have any c's. This is why we have to use a system. So each one of these is going to get their own equation. So the -1, 10. We know that y is 10. So we have 10 is equal to a times a -1 squared plus b times a -1 plus c. And then we're going to use 2, 7 to give us 7 for our y value is equal to a times your x value of 2 squared plus b times 2 plus c. And then finally, the last one, 314 is going to give us 14 is equal to a times 3 squared plus b times 3 plus c. Now, all of these are going to need to be converted a little bit. So we would actually write this one as 10 is equal to 1a plus or minus 1b and plus 1c. Our second equation, we would simplify that to 7 is equal to 4a plus 2b plus 1c. And our last one is going to be 14 is equal to 9a plus 3b plus 1c. And what that should do is ring a bell as solving a 3-variable system. Now, we have solved 3-variable systems by hand, but we also used our graphing calculator to do this for us. And remember, using the graphing calculator, what we did was use a system solver called inverse matrices. So if you remember how that worked, what we would do is take our leading coefficients for our x's, which in this case we are actually going to be finding a, b, and c. We used x, y, and z when we did the systems by inverse matrices. And you create a 3 by 3 matrix. And we would call that matrix A. So we would have 1, -1, 1 for our top row. And then we would have 4, 2, 1 for the one in the middle. And then 9, 3, 1 for our bottom row. Now remember, we were solving for x, y, z when we learned how to solve systems. But now for this, we're solving for a, b, and c. And that was equal to your constants. In this case, we have 10, 7, and 14. And we would call that b. And then remember, we just have to enter those into our graphing calculator. And then we take our graphing calculator and we would type in the inverse of matrix A times matrix B. And our graphing calculator would give us the solution. So the solution is going to look like this: 2, -3, 5. And of course that represents A, B, and C. So now we have our A, B, and C value. So the solution, or the answer to this question, after all of that work, we just have to write the standard form equation, which is y is equal to 2x squared minus 3x plus 5. Okay? And that's how we use systems, a 3-variable system, or using inverse matrices with our graphing calculator to solve and write us a standard form equation. Now again, If you remember how to use your calculator, we could do a stat of L1 and L2 and use a quadratic regression to do that as well, but, you know, had to show you the real way that it's done. All right, this is Mr. Longo, and I'm out. See you, bye.